Hello, and welcome to today's session where we'll be talking about jumpstarting the machine learning journey with Canva. My name is Ben Freebel, and I'm a solutions architect for SaaS here at AWS. I specialize in helping companies plan and implement successful AI and machine learning strategies. I'm joined today by Glenn Pink from Canva, who will share more about Canva's transformation journey, innovating with AI and ML at scale. This session is for business and technology leaders alike who have goals around solving important business problems by utilizing machine learning. In this session, we're going to be covering what machine learning innovation at scale looks like, the 7 steps towards operating successfully at scale, Canva's story, how to get started, and finally, some resources you can leverage to kickstart your ML innovation journey. For this session, it will help if you already have a basic understanding of cloud computing and machine learning, but we will be staying fairly high level. Achieving machine learning innovation at scale is about enabling data scientists and business stakeholders with the tools and processes that they need to stay agile while simultaneously enabling cloud IT members who need to ensure high levels of governance, security, and operational readiness so that they don't become blockers. Both groups have important needs, yet sometimes it seems like one has to be traded off for the other. Implementing a successful machine learning strategy requires executive and stakeholder alignment. It requires forming cross-functional teams that are all focused on security and compliance. And there are aspects of the model lifecycle development that demand high levels of experimentation and discovery. Now, for any company that's operating at scale already, they would tell you that achieving that maturity level required going on a transformation journey. In our engagements with thousands of customers, from startups to enterprise, we've observed a few common trends for what it takes to build organizations with successful machine learning cultures. What we've learned from these commonalities is a pattern of 7 key steps. And today, I will focus on these 7 steps. From establishing culture to enabling teams, this journey starts with the human element, followed by best practices for enabling your organizations with access to data. We'll talk about how to set up your first proof of concepts for success. And once you're successful with that first proof of concept, we'll talk about how to repeat this process and make sure that you can reliably operate at scale and evolve this journey. One of the best things that executives can do for their teams on the ML transformation journey is to define clear goals and expectations for what you want your machine learning teams to accomplish. For example, what type of prediction accuracy rate will drive a significant impact for your business? How can AI and ML support your overall strategic business direction? What does success look like? What guardrails need to be in place? These are just a few example questions for how to drive alignment across your various teams. Your teams also need a mechanism to know that they're working on the right projects with the right expectations. Successful teams also take a security-first mindset. Your data scientists and machine learning engineers are going to take and process huge data sets through advanced computer algorithms, and those data sets tend to be production data. You need to manage and govern that data the same way that you do with your other production systems. Now, good leaders know that when it comes to data science, it's a science, and as with any science, it's going to involve going into the unknown. Your teams may be trying to solve a problem that they've never solved before, so they'll benefit from being given the time for experimentation and to learn and advance new skills that are both technical as well as domain related. By implementing repeatable MLOps practices, you'll be able to automate what would otherwise be repetitive manual tasks, and that helps accelerate your teams to focus on what adds unique value to your business. Lastly, the best teams know they're the best because they know what they're being measured against. Maybe it's a computer vision object detection accuracy rate, or maybe it's a product personalization engine that results in increased sales and revenue. No matter what the use case, success should be measured and celebrated when it's achieved. I mentioned culture here as step 1, as though it's a step that actually gets finished. But in reality, establishing culture will permeate all the other steps. It has to be continuously prioritized, discussed, and improved. A typical machine learning project involves bringing together various roles to form a cross-functional team. Data engineers are responsible for sourcing and providing data to your data scientists. Your data engineers will be extracting and transforming data from your other production systems and databases, and providing that data to your data scientists in a consumable manner. Data engineers need robust data processing tools and the ability to quickly visualize your production data. Data scientists are generally the ones who make sense of your data. They help to identify insights or patterns that might otherwise go unseen, so as to improve or create business processes. Data scientists need access to data and powerful computing environments to experiment, build, and train machine learning models. Data scientists may also work alongside software engineers so that your other systems and applications can integrate and make use of your machine learning tools. Your DevOps engineers, or perhaps your IT admins, are going to be configuring your AWS accounts and environments, adding monitoring and logging capabilities, and automating your deployment pipelines. They'll also be working hand in hand with your security engineers, who are putting in place the right policies, alerting, and reporting to ensure that all of your teams are treating your data with the same safeguards and precautions that you do with your other production systems. Now, one thing that can drastically help your teams be successful is if they're surrounded and supported by domain experts who are knowledgeable about the topic at hand. Overall, that close partnership between your data science organization and the domain experts that they're building the models for will give your organization a head start for overcoming organizational inertia. Now, let's talk about your data strategy. It's important to think about what access do you have for your data today. What data can you make easily available to your data science teams? Or if you're starting to collect data today, what would you be able to make available to your data science team, say, 6 months from now? Has that data been labeled and cleaned? Could it be used as training data? You want all of that data to be readily accessible and consumable. If you want your machine learning models to be effective in production, they need to be trained with production data. It will help improve their accuracy and their effectiveness. The core concerns that is important to think about is data security. I hate to say this, but it happens fairly often out in the real world. Data scientists will download production data onto their laptops or desktops to work on their projects, but that is a risky approach. Now, there are two common approaches to help with data security when working with machine learning at scale. When organizations first start out, they often end up creating a separate sandbox environment for their data science teams. With this approach, you would take a copy of your production data and put it into your data science sandbox environment. Now, the benefit to this approach is that by having that separate sandbox environment, you limit the risk of accidentally leaking or destroying data or overloading your production systems. The trade-off, however, is that by having multiple environments with the same data, you may have additional administrative overhead when you want to take action or do certain data management tasks. For example, let's say you have to comply with a GDPR request to delete a customer's data, or maybe you have to update data records after they get written the first time. The second approach that organizations adopt as they continue to scale is to establish a data platform account and service. This involves giving data scientists read permissions to that data platform. The benefit to this approach is that it simplifies the data governance and data consistency concerns. A potential trade-off, however, is that if you don't set up all of your roles and permissions correctly, you could inadvertently have a user that accidentally deletes data in production, or you could overburden a production system with unexpected usage patterns or heavy queries from your data scientists. Now, when it comes to equipping your teams with the data that they need to be successful, time is essential. Getting your data scientists access to the data that they need in the time frame that they need will usually involve aligning various business and IT stakeholders, depending on how your organization treats data ownership and governance. Most of the information I'm sharing in this presentation is geared towards organizations that have already completed their initial proof of concept. But in case you're still at the proof of concept stage, here are some key considerations. Instead of starting with a generic irrelevant data science project, I recommend starting with ranking your ideas by business impact and technical complexity. Maybe you're trying to automate a business mechanism that's done today in order to achieve better efficiency gains. Or maybe you're trying to create a new capability for your users or application that doesn't exist today. Pick a low-hanging fruit with low technical complexity but a high business impact. Create a baseline for how well you solve that problem today and set a goal around the gains that you want to achieve by using machine learning. What accuracy rate do you need your model to perform at? How quickly do you need it to be able to update data and make predictions? You may have an extremely accurate model, but if that model is slower than your acceptable user experience SLAs, what are the trade-offs that you're willing to make around prediction accuracy versus performance? It's also important to think about how long you can take with this proof of concept. Now, there's no hard and fast rules for how long a proof of concept should take, but from what we found, it usually takes somewhere between a couple weeks up to 6 months for companies to complete their initial proof of concepts. Now that you've completed your proof of concept and have a functional, useful model, it's time to begin thinking about introducing automation so that your steps can become more repeatable and automated. A key difference between the previous step and this step is that for your proof of concept, you probably pulled your data set off manually as a one-off exercise. But if your use case requires making inference and predictions on a regular basis, you may want to automate your data engineering steps. A typical pipeline may have a dozen or more steps, which you see illustrated in the diagram on the screen. Now, the key to building a successful, repeatable pipeline is to first treat your machine learning infrastructure as code. That way, your entire end-to-end pipeline can be executed upon significant events, whether it's a predetermined schedule or a new dataset coming into your data lake, or a monitor that determines whether your model is no longer performing up to your accuracy SLAs. There are many ways that MLOps and CI/CD orchestration systems can integrate, but those topics will be covered in depth in other summit sessions. As mentioned before, when you're innovating at scale, core teams typically include at least data engineers, data scientists, software engineers, DevOps engineers, and security engineers. But when organizations are really ready to begin operating at scale and expanding beyond their first project, or even when you're ready to have multiple teams working on multiple projects, this does not scale easily. As you scale, a common pattern is to establish a Machine Learning Center of Excellence, or COE, that provides foundational support to all your other machine learning teams. COEs help put standard tooling and processes in place for the rest of your teams. They may also work with various product and business groups to ensure that projects are being scoped with good goals and expectations. Your COEs will be establishing a common data access platform or patterns, providing oversight and enabling team members to access data repositories with the right security and governance in place. We recommend that your COE be a cross-functional group of individuals who are also part of your actual delivery teams. You don't want your COEs to be too far away from the reality of the types of projects that your other teams are working on. One strategy that companies can take to solve this is to rotate your COE members in and out of the other project teams and the COE every 1 to 2 quarters. Now, we come to the final step, evolution. However, in reality, this process looks a lot more iterative. Organizations evolve over time by embracing an experiment and iterative-based development process. Going back to our cultural principles, it helps being experimental in nature with the guardrails in place to ensure that you're set up for success, measure your success, and iterate.
Hi, I'm Glenn Pink, Head of Machine Learning at Canva. I'm here today to share our machine learning innovation journey and some of the key learnings that we gained throughout. Launched in 2013, Canva is an online design and publishing tool, and our platform enables users to create a wide range of designs from templates, things like social media graphics, presentations, posters, documents, and we recently added a video editing tool as well. Our mission is to democratize design and empower creativity for anyone and everyone on every platform. Since launch, we've grown exponentially and amassed over 75 million monthly active users across 190 different countries. These users have created more than 6 billion designs. To enable this, Canva provides more than 100 million creative assets in the form of templates, also images, stickers, video, audio, and more content that's discoverable inside and outside of Canva. With so much content, servicing the right ingredients to the right user at the right time is challenging. And search and personalization are key to ensuring that every user finds the content they need to create amazing designs. So today, our machine learning models are embedded throughout our personalized user experience, search, and recommendations, and are really the magic that users feel while interacting with Canva's content. What you see here is an example of what we refer to as a user's personalized mixed masonry. You're probably familiar with this kind of personalized dashboard from other content providers like Netflix. Essentially, you have a lot of different components here working together to give the user a good content-driven experience. Designs and templates are surfaced to the user here and are carefully selected by a variety of different methods that are driven by machine learning. In simple terms, we know which ingredients, which colors, which fonts, templates, graphics, and also the general contextual themes that a user has used in the past. Using these and other signals or features, we try to predict similar items, making relevant content immediately available to delight our creators. What's important to recognize here is this is not one recommendation model. There are roughly 5 to 10 models at play here, some of which have outputs that are used in other models. A more obvious example where we might use similar or related type predictions are what we refer to as item-to-item recommendations. You can see 2 examples of these here, which are related items that are surfaced to the user on Canva. Generally speaking, these recommendations are just based on a single item and really only consider limited user context such as location or language. This really makes this often the simplest form of recommendations, particularly from an MLOps perspective. Results are largely the same for all users or user segments, and so we can generate these offline and just cache the results. And finally, a third example is design context recommendations, and this is one of our more advanced use cases of recommendations. The idea here is that we're surfacing content based on the actions that creators are performing while they're designing. Essentially, once you start to add graphics or text to a blank canvas, the tools panel on the left there will update based on the updated design. And really, because a user can add any content, there is an infinite amount of possible actions, and what you recommend is very specific to the user's actual context. Predictions need to happen in near real time to give a good user experience, and results caching becomes less efficient. So these are just a few examples of how machine learning drives the user experience at Canva. ML is not a singular thing we do. It's a collective term for a wide range of tools and techniques, really to make predictions from data. So I'm going to tell you a little bit about how it all started and some of the things that we've learnt along the way. One of our core principles at Canva is simplicity. We're always looking to make Canva the easiest design platform around, and this is deeply ingrained in our culture. Canvanauts are encouraged to constantly innovate for our users. To support this as an organisation, we make time for regular hackathons, allowing teams to freely choose ideas to innovate on. And more of these ideas have started to include ML functionality, and proof of concepts are often quite easy to build. But there is no value in using machine learning unless a feature can actually be deployed to production and in users' hands, and we need to be able to do this in a repeatable, consistent, and testable fashion. To achieve this, we had to break down a few silos within the organisation. For example, we identified a disconnect between the data scientists who would deliver models and the data engineers who would productionize them. Canva replaced these 2 distinct roles with a single role, machine learning engineer. Machine learning engineers are provided with the tools to write production-ready code with MLOps in mind. And this has helped reduce friction between teams, removed a throw-it-over-the-wall mentality with modeling, and helped with a lot of integration issues. Platform teams are now enabling teams for best practices and provide the guardrails for consistency, reliability, availability, and security. Coming back to the hackathons, an idea from a hackathon. This is our original mock-up from our very first personalization use case from a hackathon in 2017. And you can see here in this example, 3 different users in the mockup see different search results. The team here used AWS Personalized to build a proof of concept and an MVP in 2 days. It's very important to consider what the minimum viable product or product feature is when starting your journey on machine learning. It's very, very easy to over-engineer a machine learning feature or spend a lot of time building on the building blocks of a very complex use case. It may feel more efficient to build each component for a truck iteratively if you think your final intended product is a truck. However, you can't actually use the truck until it's done, and most of your users would have been happy with a bicycle or car anyway. The idea here is really start with something simple, as lean as you can, that adds a lot of value. This allows you to demonstrate your idea, get buy-in from the business quickly, and gives you a realistic impression of the risks and technical obstacles for production, while still enabling you to ship and go to market with product features quickly. Canary deployments and A/B testing, nothing new to us from a software development perspective, but machine learning adds an additional complexity because its output is non-deterministic. Functional testing of every possible outcome is literally impossible, and as such, the core goal of a pilot phase is to learn about your MVP in real-life situations, measure actual business value, really get into that habit of continuous improvement and monitoring. This is important as ML products in the lab can only ever estimate performance in production. User behavior, user data is constantly changing. Machine learning models need to be retrained on a regular basis to account for this. You need to know that your new model performs better than your old one. So this is what our architecture looked like going into our first MVP for item-to-item recommendations at Canva. We used off-the-shelf Amazon Personalize. To train the model, a machine learning engineer would initially manually extract data from our Snowflake data warehouse, egress to an S3 bucket, create a new dataset version, solution, and campaigns in AWS Personalize. Once deployed, Canva's backend API then queried AWS Personalize for recommendations and could surface them to a small subset of users for A/B testing. We could then gather detailed insights on how the users interacted with these recommendations. We really focused on the monitoring and targeted experiments component to measure the impact of these recommendations, and we could then just eventually roll this out and scale it up easily to our entire user base. This architecture, though, and the amount of models created evolved over time. We added more automation and more testing to this basic structure. However, after about 2 years, our needs for personalization outgrew this foundational architecture. Really, our biggest motivators for change were to standardize for other use cases outside just personalization, and to leverage things like version control and CI for code and infrastructure and automate both training and deployment. So today our architecture looks like this at a high level. We still absolutely leverage Snowflake for our training data, but we now train our models on a Kubernetes training cluster running on Amazon EKS. This is really a significant shift for model development. The delivery requirement is now a Docker container, not a model. But this allows us to mimic production as closely as possible and also define more strictly the requirements and guardrails to enforce best practices. Of course, this has required a cultural shift and a real enablement of machine learning engineers who may have in the past preferred to experiment locally or on notebook servers, but really now they have to think much more about production. Notebook services are still very, very valuable in early stages of development, but really the vast amount of data required for experiments often really makes notebooks unusable for full data sets. Moving to an environment which mimics production as early as possible is really a lot of benefits for machine learning development at scale. ML engineers, once this began, started to appreciate parallel experimentation. They would run more experiments at once, they would more effectively collaborate, and just have more peace of mind through testing and monitoring. As the CI system here, we have Argo scheduled, trained workflows that run our tests. We only push containers into the ECR repository once they pass all these tests, and this is to ensure that only tested models get anywhere near an environment or automatically pulled by a deployment process. For our integration tests, as a first step, we ensure that the container runs first and responds to requests and inputs as per the defined integration contracts. Actually testing the outputs to check if the outputs are sensible can be a bit tougher. What we've found helpful is to define failure cases. For example, the model is not producing the same output 10 times or consistently from the same inputs. Confidence values have significantly dropped. Wrong predictions are coming out for known test cases, empty inputs, or different language inputs. Once all these integration tests are complete, a simple Lambda function handles deployments to AWS SageMaker. This provides us with a flexible piece of infrastructure to deploy model endpoints, gives us auto-scaling, load balancing, allows us to monitor rollbacks, do blue-green deploys, and a lot more as a service. Every new feature at Canva goes through live A/B testing with users for some time, and ML models are no different. This allows us to compare metrics after a few days of the Canary rollout. And we have to put quite a bit of effort into defining useful metrics, establishing what it means for us to establish success. And ultimately, success is, does this model improve the user experience? Anything that you roll out to the entire user base has to have a positive impact on users, on engagement, on your core business metrics. Throughout this journey, we've also had to change the way that we think about our teams. At Canva, any developer in our product engineering teams is empowered to build and ship ML features. They consume best practices, services, data provided by our ML platform and data teams, and leverage subject matter expertise for specific use cases and domains from our ML centers of excellence. The overall vision and strategy is defined by our ML Foundations team. ML skills are still short in the market, and this setup allows our teams to grow organically with ample opportunity for growth, learning, and specializations for talent. I'm really excited about where we are today in our ML innovation journey at Canva. Recommendations are key to ensuring that every user in every location can find the content they need to create amazing and effective designs. With so much content, surfacing the right ingredients to the right user at the right time is really critical for Canva's success. We currently have about 25 machine learning models in production for recommendations, and these are at significant scale. And we really strive to become a leader in the design AI space. We're going to grow from 50 machine learning engineers that we currently have to 100 by the end of 2022. And one of our core values at Canva is being a force for good, and that means that we're actively working towards a world that isn't just good for a small few, but one that's good for everyone. We really believe deeply that bringing together diversity of thoughts, perspectives, and expression is key for building the best product for our equally diverse community.
Throughout this session, we have covered some of the best practices for achieving ML at scale. And as we said earlier, culture and evolution permeate through all stages of the life cycle. If you're just getting started and need help establishing a plan for a successful proof of concept, talk to your AWS account manager about setting up an ML workload design workshop or leveraging one of our AI and ML partners. We encourage you to get engaged with our training and certification content today. Scan one or both of the QR codes on the screen to get started with your cloud skills training and certification. And with that, I'd like to thank you for watching the session today. I hope that you found this information useful. And finally, please be sure to complete the session survey. Thank you for watching.